Alright, so in this video lecture we are going to learn and explore everything, every single detail about the logarithms. Alright, and so I have to say this before we get started, the pre-calculus course that you are learning currently, and this lesson here is intended for the viewers, the audience who are in a pre-calculus course or somewhere some other institution may refer to the course as a college algebra. But nowhere, no other course will learn about the logarithms as much details as this course here that you're taking. Alright, so allow me throughout the entire lesson here, the entire lecture here about the logarithms, allow me to bring in quite some in-depth details right here, because this is where you build your solid foundations on the understanding of the logarithms, so that later on it will become extremely useful in your calculus course. And as again, I've mentioned this in some other videos before this lesson right here. This course you're learning is a pre-calculus course, so you are learning all of those details that preparing you for the calculus course that you will later on taking. Okay, so as a prerequisite for this lesson right here, it is extremely important, and it is a requirement that you view this lesson. Anyone learning in this video lesson here, you must view this lesson after you have already learned about what an exponential function is, and you have learned enough details about how to operate and as well as how to work with the graphs of an exponential function before you can have a full understanding about the logarithms. Okay. And then it is highly recommended that this particular part of the lesson here, okay, at this particular part where I first introduce about the logarithms, and it is highly recommended that it's being viewed after you understand about what a function is. However, it's not a must that learning about the logarithms has to be after learning about what a function is. Okay, but it's highly recommended. All right, but other than that, let's get to it. Okay, so now, to maximize the amount of board space, I'm gonna go over to the other board space of mine right there. We're gonna switch to the other board space, and we're gonna get started to understand what a logarithm is. Okay. All right, and to begin with our journey, I have to be clear at start. The point now is that we should be able to understand about the logarithm even without the need of a calculator. Okay, so let me first. We no one need to worry about what a logarithm is at this point yet. Let me bring in the following couple questions that you should be able to answer within your own mathematical capability, within your own mental math capability, to be precise. Okay, so let me bring up the first question. So how about my question is addressed as following. I would like to find what power, okay, or it's the question itself, what power of base 2, okay, what power of base 2 equals 8. All right. So it's a question. What power of base 2 equals 8? What power of base 2 equals 8? There are a couple elements in this particular question right here that need to be underlined right here. So allow me to quickly grab my red marker. All right, so I would like to underline base 2. What power of base 2 equals 8? So to assist, as a way to assist our thought process, I highly recommend doing the following. So in the end, we're still looking for an answer to this question, but in order to answer that question, and again, I'm not saying that we're going to pull out a calculator and boom, here you go, here's your answer. That's not how it works. Okay, so let's see how our thought process can work here. So what power of base 2 equals 8? So the idea of base 2, and this is the reason why I require anyone viewing the lesson here I require anyone viewing this lesson to view this particular lesson after you have already learned about some exponential function. Okay, because here base 2. But what power? So we don't know what power. So power is written as a superscript. So base 2, okay, but what power? That's why I'm leaving it as an empty box. So drawing this quick little picture right here helps our thought process. So what power of base 2? I'm leaving it empty. Base 2, that equals 8. This is our question. So I put question mark here. The question here appears to be, we put question mark here because that power now is the unknown. All right. And so now this is how I was able to say earlier that within our mental math capability, we should be able to quickly find this answer. We don't need a calculator for this. Apparently, 2 to the third power, so power 3 of base 2, power 3 of base 2 equals 8. All right, so now we found the answer legally and officially. Now we found the answer. So power 3, I answered that. I put that answer in red ink right here, and I put it right inside of that box. Okay, so power 3, the answer is power 3 of base 2. Power 3 of base 2 equals 8. And so now here's our answer. Okay, the answer for this is 3. Okay, I put that. What power of base 2 equals 8? I found the answer, 3. All right, let's try another one. Okay, I'm going to repeat the exact same question right here. Allow me to erase this small little work right here. But I'm still going to retain that. So this is a question. That was the answer. And I wrote down the thought process, and I just now erased it. So let's repeat the question again. So allow me to address the question, another question. So what power of base 5, okay, equals, so how about 625, okay? So as a complete sentence, as a complete question here, what power of base 5 equals 625? What power of base 5 equals 625? And so there's a reason why I still leave this earlier question here. Before we make our attempt to answer this question, quickly as an observation, this question, the structure of the question looks exactly the same as the structure of the question previously stated. Okay, it's just here I switched to related to a different base. I switched to asking this question in regard to a different base here, base 5 instead of base 2. Okay, and then there's a number, so there's always a base, and that's why earlier in the previous question I underlined that base. That's one key element. So here I underline that again. What power of base 5? So I want the base to be 5, but I'm particularly looking for the power. So in that way, before I get to the answer, and of course, right now it may seem that I'm slowing down your thought process, but because I want to break it down to the clearest level, okay, so that anyone from with the minimal background in math can still understand. Okay, it's just some reality that already lives in our mathematical nature, but now it's time to formalize the idea right there. Okay, and so you all know these things. It's just now we bring it to light and start looking at it a little more seriously. So base 5, as underlined right here, but I'm not. So base 5 is we already given base 5, but we're looking specifically for what power. See what power. So right now, that box right there as the power is the unknown. I'm leaving it empty with the question mark in there. Okay. See what power of base 5? That equals 625. What power of base 5? Okay, equals 625. And again, I don't think anyone would need a calculator for this. Trust in your own mental math skill and believe in your own experience with math. In math at this point right here, you know it. This answer here must be power 4. Okay. So the power here now must be power 4. So drawing this quick little picture right here helps. Okay, it's just a way to assist. So I'm not saying that you have to always do this. Nope, that's just here as I'm teaching, I'm laying down the step that shows the thought process right here. Throughout my years of teaching, I found this thing here visually brings it out to light for the students to learn and catch the idea. So now that answer here, but to get that answer really, it's just your mental math tells you that. You believe in your own mental math capability. Okay, power 4. So why is that? Or earlier, how did I know it's a power 3? 2 times 2 times 2, 3 times, or 3 identical factors of 2 multiplied together. That's what power is all about. 3 identical factors of 2 multiplied together, that equals 8. That's how, base 2 to the power 3 equals 8. And so in that same way, that's how you can verify yourself. How do I know? How do you know? How does your mental math mind know? The answer is 4. It's power 4 of base 5 equals 625. Because, this is simply because 5 times 5 times 5 times 5, 4, we just simply produced a product of 4 identical factors of 5 right there. Okay, that's why it's base 5. All right, and now the answer to this is 625, and that's how we know it's 4. And again, like I said, this is ultra basic stuff like that, and so you can trust your own the mental math capability right there. All right, and so now, let me erase that quick part right here. So this is just a way to assist our thoughts right there. The formal answer to this now, the answer to that question is 4. The answer to that is 4. All right, and so now with 2 questions right here, we are starting to formulate into a certain generality already. So again, still having with the 2 questions are still being retained on the board here. Again, one more time, I would like to trigger that attention point of yours right here. The 2 questions here have one common structure. What power of a given base? So the base here in the earlier question was given to be base 2. So what power of base 2? What power of base 5? And then there's a number that equals 2. All right. There's a number that equals 2. So really this is just part of the question. So we want some power. We want some power so that base 2 raised to the power that equals 8. So this is sort of like a requirement. 625 here is the requirement for this question right there. 8 is the requirement for that question. We want the power. We want to find the power of base 2 in the requirements, under the requirements that the overall equals 8. Okay, and so that's why our answer to that requirement is here. Okay, so the same way over here, we want to look for that power of base 5 under this requirement that makes the whole thing, power of base 5 equals 625. All right, and so I can put in as many questions like that as possible, and I purposely would like to point out that this kind of questions exist very intensively out there in your daily life right there. A lot of times we ask ourselves a question: what power of a given base equals this number? What power? So equals this number, that's not the answer. The power that we're looking for, that our mind is working mentally to look for, that's the answer right here. So when I addressed this question right here, our mind was already, and that's why I was saying, believe and trust in your own mental math skill right here. Your mind was working in the behind the scenes to mentally come up with these answers right here. Okay, so now after we have seen enough and I've emphasized enough the repetitive structure of in the 2 that appeared in the 2 questions here, and no matter how many more times I'm addressing other questions, it's going to be the same. What power of a different base? What power of another base? Like that. So now it's just all about a way to conveniently write it. It's just, you see, I wrote the question 2 times. It took me 2 minutes writing each question. 2 minutes writing each question, if I estimated myself correctly in terms of time right here. But see, the point is, it takes a long amount of time to write a lengthy question like this, to write a lengthy worded question like that. Okay, so for convenience, it's just a convenience right here, and that's the way how math people do. We try to come up with symbols and notations to replace worded sentences, worded statements. Okay, so my statements, my question here is a worded question right now. So what power of base 5? What power of base 2? What power of base 5? See, that common structure is what power. We're looking for the power. Okay, what power of? So now, ladies and gentlemen, I introduce to you a symbol. It's a symbol. It's just a notation. One symbol, we read log. Okay, this symbol over here, log, this symbol replaces the whole phrase what power of, okay? And so now in this particular question, what power of base 2? So now I put the 2 here as a subscript, okay? So the base is indicated as a subscript. So log now is all of a sudden, it's just a symbol that we use. One symbol here represents one big structure of the question already. What power of or in regard to base 2? What power of base 2? That's required to equals 8. So now formulating the whole question here. The whole question earlier stated in worded statements, was a worded question. Now it's written in symbolic form as a notation, a much more convenient way of writing it. So this is a question I would like to emphasize. I want to address and I want to emphasize that this is a question. It's a question. What power of base 2 equals 8? All right, that was our question. And then optionally, we can, a lot of times, we can skip. So the same question, what power of base 2 equals 8? Okay, so we can sometimes, or quite sometimes, skip the parentheses as the first version I wrote here. All right, so, and I'm not rushing into the putting down the answer. So far this is a question. That is a question. It's just the symbolic expression of a question. Okay, a symbolic way, a symbolic written form of a question instead of the worded written form of that same question right there. All right, so now let's just apply our understanding immediately. Let's just immediately apply our understanding, and it doesn't even need to be a formal example. What power of base 5? What power of base 5? So what power that will immediately click my attention? I can conveniently use log as a symbol to say what power? What power of base 5? So base 5, as soon as being recognized as base 5 in the question right here, we put that as a subscript. Okay, and then the formal version. What power of base 5 to equal 625, so I put the 625 in parentheses. Ladies and gentlemen, that is another question for us right here. It's a question, okay? It's a question. It's a question, and this is a skippy version of a question right there, okay? A sketchy version where we skipped parentheses, okay? And so it's just my style. I don't highly recommend using this short version, even though it's quite accepted out there as well. But so allow me to stay with throughout most of my lecture over here, allow me to stay with the formal version where I put parentheses around. So the number that goes, the part that goes inside the parentheses is not the answer. It's not the answer. The whole thing is still a question. We want what power of base 5 under that requirements to equal 625. What power of base 2 to equal 8. Just exactly like the way how the question was stated in words here. All right, and so now here's how we put all the elements together. We have already found the answer to the question here. The question here, we already found the answer previously. The answer to that question was 3. And so now here's how I'm stating it. So mathematically speaking, as a mathematical or as a symbolic statement, I'm saying, so to answer this question, log base 2, or here's what power of base 2 equals 8? The answer is, that's why equal sign comes in. The answer is 3. All right, log base 2. So now formally we say it. Formally, this whole symbol right here, this is how we read it. Log. All right. With that symbol right here, it's a question before I'm putting, so this part right here on the other side of the equal sign, starting at the equal sign, it's the answer to the question. The whole symbol here is a question, okay? This is the meaning of the question. But now allow me to introduce how we can pronounce, okay? How we can say it out loud, this symbol over here. So this symbol reads log base, so with the base here, log base 2. Okay, and then more specifically, log base 2 of 8. Log base 2 of 8. It's even verbalizing out the symbol here. It's still a lot shorter than stating the actual worded question. So it's in the end, it's still a lot more convenient. But I want to emphasize again that this is a question. Log base 2 of 8, it is a question. It's a question asking for, hey, what power of base 2 that equals 8? And so now the answer is here. Okay, the answer is here. So now, so putting it all together, here's another way of reading it. In incomplete question and answer. Question, this is question. Question and answer. Log base 2 of 8 is, or you can say equals, okay, log base 2 of 8 is 3. See, the answer to this is 3. All right, so now in that way, this symbol represents the whole phrase of our worded question here. So now the complete symbol here reads the way how we read it: log base 5, okay, of 625. Okay, that's one question, and even if we are verbalizing it right out loud right now, it's still a lot more convenient than saying in a complete full statement, what power of base 5 equals 625. This is the actual meaning of this question, but this is a more symbolic way of addressing that question right there. So now I say log base 5 of 625. It's a question. It's a symbolic question. The meaning of the actual question is here to truthfully understand it. All right, and so now the answer. So back to like how I was explaining that here. So it's a question. We have already found that answer here previously. Okay, we have already found that answer there previously. So now I can officially say, I can legally say log base 5 of 625 equals, okay, this, because that's the way how we read it out loud right there. Okay, but now as a question, well, the answer to this question, what power of base 5 to equal 625, the answer is 4. The answer to that question is 4. All right, so question and answer. All right, so now here's only question so far. Log base 5 of 625, that's question. So in a complete symbolic form, but question and answer, in a complete question and answer statement, then I'm saying log base 5 of 625 is 4. Log base 5 of 625 is 4. All right, so ladies and gentlemen, this LOG symbol right here is short for, so the action, the work, the thought process to look for the power, to look for that answer to this question. The question is symbolically represented by the log symbol. We're clear with that at this point. Okay, we're clear with that at this point. But then, so the work to find that is called an operation. So here, so the work to find the answer, our thought process there is referred to as, and that's why they use this symbol over here, the logarithm. Okay, so log is now is short for log, just that LOG right there is short for logarithms. Okay. Logarithm. All right. And logarithm on its own is an operation, is a thought process right there. It's so we write that. I introduced this as a symbol, the LOG. Yes, it's a symbol. It's still a symbol. So together it's a question. But then in order to answer that question and our process, our thought process to find that question, then that thought process there is referred to as the logarithm operation. All right, the whole thought process to come up with final answer, okay, or the work that we apply, the work that we are doing to the number 8, the work that we are doing to number 5 right here is called the logarithm operation. Okay, so log is short for the logarithm, and logarithm itself is an operation. Okay, so now on this board, allow me to add in a little extra note here. But so logarithm is an operation. All right, and so at this point, for anyone learning in math here, you are mature enough to know that an operation is simply things that we do to numbers, things that we do to mathematical values. Okay, so since we're little, we've learned about addition. So addition is one operation that we put two numbers together as a total count. Each number represents a quantity, so putting together as a total count, we come up with what's so-called an addition operation. And then there's subtraction operation. It's another operation. So we've known all of these operations, a lot of those. So now when you are mature enough at this point that you are taking a pre-calculus course we introduced for you, right? You are introduced to another operation, okay? It's a logarithm, okay? So logarithm on its own, it's an operation to represent a process, but it's also a question on its own, a question that's asking. So when we're saying it's log base 2 of 8, right? You're saying it like that, but it means it's a question. You're asking yourself, log base 2 of 8, okay? That's a question. What power of base 2? 2 equals 8. And the answer to that is a 3. All right. And so now at this point, I wrote this down not too long ago, but allow me to erase that and start writing down a formal definition. So understanding the logarithm, or understanding a log symbol, the log base 2 of 8 or log base 5 of 625, okay, understanding that through a question is my style of approaching it. It's my style, and I feel I've been successful throughout my years teaching students, anytime introducing the students to logarithm. So in order to find an answer, think of that question. Okay, think of that question, log base 2 of 8. The answer to that is 3. Why is that? Because think about what power of base 2 to equal 8. Okay, and so, but now as far as when it gets to a formal definition, okay, then, you know, no matter how independent my teaching is to any textbook, but in the end, when it comes to a formal definition, let's stay with this definition where any textbook in the market, okay, any textbook being sold and being written out there use the exact same definition because it's the way it is. All right, so now as far as the formal definition, let's look at the formal definition. All right, so again, at this point, log base a of a number. We understand that in my way of explaining it, it's a question, okay? So what power of base a, what power of a base given base a to equals x right here. It's a question. So that question equals to an answer. The answer. So if y is an answer to this question, if y is the answer to this question, the log what power of base a to equals x, if y is the answer to that question, that means, so now this double head arrow here for our level right now, let's take that as means, or exactly means. The answer to that question means base a raised to that value y must equal x. Isn't that what it is right there? Because, see, this is a question. So this is aside from the formal definition. This is already the definition. But let me illustrate again. So what power of base a, okay, that's what the log subscript, the a is for. What power of base a, okay, equals x, okay? So this is a question, that's a question. And so if y, if the answer is y, then that means, see, when I was explaining it earlier, I was using the box thing, okay, and then an empty figure inside of the box because that was unknown, but that's our answer right there, okay? See, what power of base a equals x? So now if the answer is y, so we have a to the y equals x, and that's why we have this equivalent statement right there. All right, so ladies and gentlemen, this is now the formal definition. I'm not saying that we have completed the formal definition, okay? But this is the biggest part, the most core understanding about the definition of a logarithm, okay? That's delivered, that's written in any standard textbooks being written and sold out there. So now so throughout the problems, throughout those questions I addressed right there, there's another truth behind the scene that I was not mentioning earlier. Now it's time to get to it. See the bases here that I was looking at. This is base 2, that's base 5. Okay, the bases have to be a positive base. Okay, the base have to be a positive base. Okay, so now I'm adding into this definition right here, where, so this is the primary understanding about what a logarithm is, but now another requirement right here, the base right here has to be a positive value. It has to be a positive value, and further, there's one more thing. Okay, so now let me get back to the other board and clarify a couple things. So just now I was saying the base of a logarithm operation must be a positive. Why is that? So now we can immediately verify that understanding. What power? So why does a base have to be a positive value? Well, then pick a negative value then. Okay. Well, what power of -1 or -2? Equals 8. Okay, I'm just stating what power of base -2, okay, equals 8. Let's see if we can find that answer. Let's see if we can find that answer. So I want -2 as the base. We want to raise this to some power, and that equals 8. Okay, I challenge your creativity right here, or your thinking, your thought process right here. Find for me what power of base -2 to equals 8. Just that exact thought process I was laying down earlier. Okay, and this, yes, tentatively we're trying to explain why we don't want a negative base. So if we write this as a question, then log base -2 theoretically of 8. Okay, that's the question. But see, what matters here is, can we really find an answer to this? Okay, base -2 raised to a power. What power is that? It's such a mystery. Nobody knows. All right, at least I don't know it. I've been trying this for a long time. Never found anyone, and I haven't heard any news about anyone on Earth found an answer to this. Okay, and so in that way, that's the reason why we cannot go negative number for the base. So logarithm, okay, or this question only utilizes positive base. Positive base. Okay, so why not 0? Why not base 0? What power of base 0? Okay. And you can try this independently on your own as well. You can verify your own thought process as well. In my definition, I was stating that we work with log. Under that requirements, the base has to be a positive value. So I put in that question to trigger your attention right there. So negative base just doesn't work, and that's why we don't want negative base already. But why not 0? Why not base 0? Okay, and so what power? So there you go. Bring in the same question right there. What power of base 2 to equal? Well, pick a number. Okay, equal 5 to equal 5. Okay, what power of base 0 equals 5 right there? Okay, so base 0. This is even impossible. We won't even be able to find an answer. Okay, and we know for sure. Now there's a case that if the question happens to ask what power of base 0 equals 0, okay, what power of 0 equals 0, then it's still scary in the sense that there can be infinitely many answers. There can be a 5 here. There can be a 6 here, and there can be a negative 3 here to all equals 0. So a lot of answers there. So this is the part where, you know, for one particular part, right, for under one particular requirement, it works with infinitely many answers, and then the other than that, it has no answers. So this is a scary situation, and that's why we don't want to include that base 0 in our logarithm work right here. So now again, back to the formal definition. Anytime we're working with the logarithm operation, okay, log base a of x, log base 8 of x, that's how we are reading it, the symbol out loud, but it means it's a question right here. We want to find what power of base a equals x, okay, and then if the answer is found to be y, it means a to the y equals x. But in the end, this operation only works if we are working with the positive base. But then I'm leaving an open and right here. So and what? What else? What else is still out there? All right. So now, ladies and gentlemen, allow me to bring in another question. See, anytime, let's start putting at least if you are studying with me right here, I highly recommend anytime you're working with log, bring in this question. Bring this question in. Okay, and it helps you answer a lot of questions about calculating log value. Okay, what power of base 1 to equals, pick a number, 3. Okay, I picked that on my own creativity. You can try that on your one number on yourself like that, but the base, I purposely want to focus on base 1. Earlier I addressed that question for a negative base. I used base 2 here, but it representing any other negative base didn't work out. That's why we wrote it out. I used base 0, didn't work out. Okay, and that's why under one requirement working with logarithm, we only deal with the positive base. But now I address base 1. It's already a positive base. Okay, let's find out. So symbolically, as a question, but as a symbolic question now, log base of 1. That's how I read it. Okay, if this base works, I mean, if this logarithm operation works, log base 1 of 3. Okay, that's the question. The question, but and the same question in symbolic form right here. Okay, but what's the answer? What's the answer? Okay, so we're gonna bring in our thought process like before. Base 1 raised to what power? So I'm going to leave an empty box right here. Hopefully our mind can start telling us, hey, what number can we fill in here to equal 3? Take a moment to think for yourself right here. Does 1 go in here work? No. 1 to the first power equals 3? No. Does 2 go in here work? Does 2 going in here work? No, because 1 square is not equals 3. Does 5 go in here? Does 5 going in here work? No. 1 to the 5th power is not 3. Okay, and so what about negative number here? I mean, power can be negative, and we have learned that. We've been fluent with that since our time learning about the exponential functions, and even when we learned the basic understandings about powers and exponents in our previous course as well. Power can be negative. Think about negative 5 right here. Does 1 to the negative 5 equal 3? No. Okay, and we try 0 here. It doesn't work out. So none of the answer here will work with this. We can't find an answer. That's just a quick demonstration. And this is the reason, and that's why log base 1, we shouldn't put that in our consideration. It's a completely separate world. So logarithm only works on base. We only work with positive base and a base other than 1. All right, that's what my point is. I raised all of those critical questions there where we are not able to find an answer. And so now with those questions, those critical questions regarding the base of a logarithm that we are not able to give a definite answer, we rule them out. So we only handle the logarithm with the positive base and base other than 1. All right, so at this point, after seeing the formal definition of a logarithm, okay, so this is the way how many textbooks is is addressing it as a formal definition of what a logarithm is. But now, to keep it easy for anyone, I highly recommend going through your thought process as how I was stating those questions there. Okay, a logarithm is a symbolic way to represent those questions again. Okay, so now let's start getting ourselves comfortable with that with the logarithm by going through our first example here. All right. All right, so here we go. Let's call that example 1 right here, and here's the worded instruction. We're simply going to learn to evaluate. And the intention of this problem, of this example, is to have anyone learning from this lesson to evaluate without a calculator, and to start working on your mental math capability a little bit. Okay? Doesn't mean to put so much challenge on you right there, but these are, again, believe me, simple enough that my mental math capability can lead me there. Your mental math capability can lead you there. Okay, it doesn't make much difference between instructor and students here for this kind of problem. Okay, not because I'm teaching here doesn't mean I know and you don't know. Okay, you will know. Part A. So, log base 2 of 16. Okay, so this is the recommendation. So by the way, alternatively, you may see a lot of times textbooks or other instructors or professors may also write this without the parentheses. That's another alternative form, but I highly recommend using this parentheses version. Okay, but now it's a question. It's a question. So what question is that? So at this point, the question that I explained earlier, that question is not something that we can just directly write in here. We don't want to write down the question, but keep that question in mind mentally. What power of base 2? See? What power of base 2? What power of base 2? So base 2, what power of base 2? 2 equals 16. This is not the answer to the question. This is just the requirement. We want the base 2. So once we found this, that's the answer. All right, so a few more times I'm repeating that thought process right there. All right, so now my mental math capability told me, and I believe yours is the same. Okay, the answer is 4. 2 to the 4th power equals 16. 2 to the 4th power equals 16. Because, see, and this is how we can verify ourselves right here, because 2 times 2 times 2 times 2, that's what 2 to the 4th means. It's a product of 4 identical factors 2. That's why 2 becomes the base, and the number of repeated factors, 4 of them. Okay, and so now this basic multiplication, that's 16. Yes, so that's why now 4 is legally our answer. And again, I said throughout most of the rest of my lecture, there are not too many times I'm using this short symbol right here where I skipped parentheses. So it allowed me to erase that, even though you are allowed to use that as well. But watch out that sometimes it gets a little hard to understand if we skip parentheses. So I want my students to get into this habit using parentheses. Okay, but so now that's a question. The answer now is formally 4. And that's how we're doing it. Now that's our answer. Okay, and that's what I meant. That's what it's meant for evaluating. That's what it means by evaluating a logarithm. Okay. So it's an operation, and we operate on 16 right here, and we come to an answer 4. Okay. All right. So now let's move on to another question. And so my purpose of bringing in this example 1 is just for anyone to start getting comfortable with the standard routine of how we answer or how we come up with the answer of a logarithm operation. The answer is simply just look for that answer of the question, what power of the base to equal this? Okay, and then whatever that power is, it's your answer to the logarithm operation. All right, now we're ready for part B. Okay, how about log base 3 of 27? So reading it out loud just like that. Log base 3 of 27. But it's a question, really, it's a question. Okay, looking for the answer, think about it this way. What power of base 3? See, base 3, what power of base 3 equals 27? Okay, what power is that? And now our mind can tell us mentally. Okay, our mental math capability should be able to drive us there to that final answer. 3. Okay, and then even if you want to clarify yourself or verify yourself, well, why is that? Why is the answer 3 here? Because 3 times 3 times 3, it's a product of 3 identical factors, 3. That's why. Okay, so now that's after the product, it's 27. All right, and that's why the answer here is 3. That's how I because at some other times, logarithm operation can get a little confusing, especially pre-calculus is usually the first time where you get exposed to learning about logarithm. So it will get the confusing sometimes. So anytime you see this, think of that as the question I've been stating out. Okay, the question, what power of base 3 here, what power of base 2 to equal 16, what power of base 3 to equal 27. That will lead you to your answer a lot easier, and I don't think you need a calculator for that. Okay? All right, let's try again. How about log base? And so let's check again. Are these logarithms consistent? And when I'm saying consistent, meaning are they aligning with the proper requirements of logarithm? And all of the requirements on the logarithm is mostly about the bases for now. Okay, the bases are what? Positive and positive. So we were all good to go, and that's why we were able to find some answer. Okay, so now log base. How about log base of 4? Okay, of 16. Okay, log base 4 of 16. All right, and so base 4, we want to find what power of base 4 to equal 16. And now the answer is easy. It should be, and it must be 2. All right, and that's our answer. All right, and then we can do another quick one right here in this little space right here. Log base 5 of 125. Okay. All right, so once again, in order to obtain that answer, think about base 5. What power is that to make it final 125? Okay, what power is that? So it has to be power 3 like that. Okay, and just simply with a little bit of mental math skill should be good enough for us to drive to the answer like that, to lead all the way to the final answer. All right, so that's the entire aim of this particular example right here. That's just to get you comfortable. Okay, so now let me bring in one more little question in this particular example 1, and then we're gonna be completely done with example 1. Okay. All right, so yes, so far I've been emphasizing and make it look like it would be beautiful if you can answer these questions without a calculator. That's ideal right there. Okay, but of course there will be cases, there will be times where doing this work we go a little beyond our mental math capability. Okay, let's say question E right here. We want to find log base 5 of 10. Okay, reading it out. Log base 5 of 10. Log base 5 of 10. In the way how I have explained it, it's a question. It's a question. Okay, what question is this? What power of base 5 to equal 10? All right. Power 2? 5 to the power 2 equals 25, not equal 10. Power 1? 5 to the first power equals 5, not 10. So we tried 2 different answers, didn't work. So it has to be some answer somewhere between like that. Okay, so ladies and gentlemen, yes, it would be good if you can do the math mentally, but of course, anyone's mental math capability, including my mental math capability, will reach a limitation at some point. So with a problem like this, we do need a calculator. Okay, so yes, that's the way for us to understand our goal right there. That's the way for us to understand our goal. But in the end, without a calculator, we won't be able to figure this out. Okay, so we're still leaving this as a mystery right now. Okay, I'm not saying that it doesn't have an answer. I am not saying it doesn't have an answer, but we need a calculator for this. So here we just simply need, okay, we need a calculator because there will be at some point things will go beyond our mental math capability. Okay, so now we will get to a little bit of time throughout this lecture or some later lectures where we're still learning about logs, where I will introduce how to use the calculator. But let's just have a full understanding of what the logarithm is first before I show the calculator, the command to find the answer here. So for this particular question right here, that's all I'm saying. We need a calculator, that's all. Okay, and then now, because I'm in the role of being the instructor here, so I already know the calculator command right there. I will bring it in later, much later, but for now, allow me to just only swing by my computer station and grab that answer from my calculator and put it here. But then again, be aware, that means I owe you an answer for this, of how I use the calculator to get this. Okay, we will get to that point. Right now, all I want to show is that there will be times where calculating a logarithm value will go beyond our mental math capability, where we need a calculator. Okay, so all right, so from my calculator, I found it's approximately equal, and it's a very lengthy value, okay? And I'm going to just round to about 3 decimals, but so if you are asked later on in our lecture here, if you run into a problem like that where you have to use a calculator, then watch out for the rounding requirements in different problems that you're doing. So here, just as for lecture purpose, I'll go with 3 decimal places. So 1.43 and 1, I round it to 3 decimals right here, but this thing is a lot longer than that, okay? So it's about 1.431, and there we go, we found the answer to that. But see, I had to use a calculator for that. It's way beyond my mental math capability already. But here's what we can check for consistency right here. I brought this up earlier. Power 2, if the answer is 2, it's not going to work because 5 to the power 2 equals 25. Way too much for 10. Answer is 1? No, because 5 to the first power, 5 to power 1 equals 5. Way below 10 right here. So the answer has to be a number somewhere between 1 and 2. The answer is somewhere between 1 and 2, and the calculator gave me this. Okay, so that's just some more developed understanding about that. That's all we need to know right now. All right, so at this point, after example 1, we are ready for heading out for some more details. We have to start out the learning about logarithms by building for ourselves a solid foundation of the understanding about what a logarithm is and all that. And then we keep putting in more details and more details. And then eventually, okay, at some point, we will use that idea and come up with what's so-called a logarithm function. So right now, you got to understand my main aim here, my main intention here is to make anyone learning from this lesson fluent with working with logarithm. First of all, as an operation, like learning how to add, learning how to subtract, learning how to take square root. Then here we learn how to take logarithm. Okay, you don't need to worry about, eventually you have to learn about the log function or anything like that. Okay, let's leave all of those fancy ideas out at this moment. All right, so now after looking at example 1, allow me to focus on the following details right here. Let's have a closer look at the basis. Okay, the basis of the log. So we have agreed, after looking at the definition, that the base has to be a positive base and a base other than 1. But those are all of the requirements. Okay, those are it. Okay, no other requirements needed here. So what does that mean? So now It's not an example. An example is, in my style of teaching, an example is a place where you can repetitively or repeatedly practice a skill along with my guide like that. But I will also bring in a lot of other examples where I call demos problems so that you can illustrate the idea and lead you into a new idea. Okay, so here it's sort of like a few demo problems right here. So the only requirements we need is a base for a logarithm, a base being positive and a base being other than 1. So now think about it this way right here. I can come up with a base being, because we're all fluent and at least we have done this throughout the whole example 1 already. So using a base being a whole number is perfectly good. Okay, base 2, base 3, base 4, base 5, we can work with a lot of bases, right? Okay, so now base 10, still a whole number. Okay, let me bring in one little demo problem for here. Log base 10, let's evaluate it. But this is simply just a demo problem right here. Okay, log base 10 of this is what 10,000. Okay, 10,000. Okay, so in order to find that answer, once again, base 10, what power of base 10? See, use that question right there is a perfect way to assist your thought process to come up with the final answer here. Okay, what power of base 10 equals 10,000? Now your mental math can kick in again, and we don't need calculator for something like this, for something this simple. Power, see, here for 10, base 10, we count a number of zeros, right? So the answer here is 4. All right, so now that answer is 4. All right, so the base for this problem is just like that. This problem here is base 10. It's still a whole value base right here. But I brought in this particular problem here for a reason. Okay, it's not just to challenge you one more time with your mental math skill. It's not something like that. It's not anything like that. But now it's just the way how all of the mathematicians worldwide, including me as a math teacher and with many other math professors out there, we come up with the following convention. Okay, it's just a convention. It's just a convention, an international agreement among all worldwide mathematicians that anytime it's log base 10 right here, okay, is log base 10 is written as, so we even use a shorter symbol. So on standard, it's log and with the base indicated as a subscript. Log and comes with a base indicated as a subscript. That's why I've been using with that standard right there. Okay, but now anytime it comes to base 10, okay, log base 10 is written as, that's why I'm writing that in red ink right here, just log. Just log, that means the base at the as a subscript right here, that base as a subscript is skipped anytime it's log base 10. All right, so only for log base 10. Keep that with you. Okay, so and this is one, I label this number 1 as far as the convention, because there will be another convention coming later. But for now, the first convention for here that's being used worldwide, that anytime we work with a log base 10, anytime it's log base 10, then we write as a log, completely skipped the base. All right, so now right from this understanding, right from this impact right here, right from this understanding, then the same question I addressed up here, the same problem I addressed up there. Okay, and that means now I can legally write, and this is now no one in the world in these days writing log base 10 of 10,000 like I wrote earlier, because that was only to put your thinking into a new direction. Okay, but now once we've understood about this convention, everybody else in the world is writing this way. Log, no base, no subscript. Okay, log of 10,000, and you must automatically understand this as log base 10 of 10,000. Okay, and then so now that answer there again, nothing disagreeing with the earlier ones. The answer is 4. Okay, it's just here I purposely brought up this base, this particular base, okay, to indicate that as a worldwide convention, as a worldwide agreement, again, that we use just the symbol log and completely skipping the base. Okay, so and anytime you're seeing the log with the base without a base indication, that's understood as log base 10. All right, so hopefully anyone is clear with me on that. And so now at this point, you got to be aware, you must stay with this requirement. I mean, with this convention right here, don't write log base 10. Okay, that's because nobody else in the world is writing things like that. Even though it's not wrong. Okay, it's not wrong, but it's just nobody else writing it like that in these days. Everybody else is writing log only when it comes to base 10. Skip the base. All right, so that's one convention. And now allow me to erase this convention. And so now let me get even further. So along this way, you can see that I would like to focus more on talking about those details about the basis of a logarithm. Okay, so here you can see this as a subtopic, basis of a logarithm. Okay. And so just now I talked about base 10, and we have a worldwide convention. We skip the base, okay? So that's one thing we need to understand about the basis, the basis of a log. So now another thing about those bases. So back to the definition. So the base, again, I addressed this earlier. Positive base only. We only work with that requirement, and a base other than 1. Okay, a base other than 1. And so in that case, that means nothing stated that we have to work with whole value base. So I mentioned about whole value bases earlier, and we use only whole value base throughout the entire example 1. Okay, and even the earlier case where I brought up the base 10, it was a whole value base. But now think a little further, okay? Think about this detail as a little further impact. Right out from the definition, right out from that definition. Nowhere in the definition says we have to work with whole value like how we did with the base 10 or base the 5, base 2, base 3 in the example. Okay, and so in that case right here, now let's get you really comfortable. We can also work with a base being a decimal base, okay, like a 0.5. Okay. So log base of 0.5 of a 2. Okay, log base 0.5 of a 2. This is completely a legal and an official logarithm question right there. What power of base 0.5 to equal 2? And just because the base appears to be a decimal doesn't mean it's way beyond. I'm not saying that you can still always do this, but just because we're seeing a decimal base like this doesn't mean that, we immediately look for a calculator. No, I'm still not going to intend to switch over to my calculator yet. Of course, we still need to be a little more advanced right here, but we can still do the math here mentally. Okay, 0.5 is a 1/2. So another way of saying that, what power of the base 1/2? Because 0.5 is a 1/2. What power of 1/2 equals 2? All right. So with a little algebra understanding, we understand that 1/2 to raise to a power -1. That's our answer. So now I brought in this demo problem right here to start opening up a new light for us. Any base, a base to a logarithm, the base to of a logarithm doesn't have to be whole value. It can be a decimal, like in this case right here, 0.5 right here, and then 0.5 is for this problem we can still do the quick mental math right here, because 0.5 is understood as a 1/2, so 1/2 to the -1 power, yes, that equals 2, because we take the reciprocal. All right, so now along that way, and I'm not saying that all problems with the decimal base can be done without a calculator, and so eventually, yes, it will come to that point where I will show you how to operate with a calculator. But just here we try to push ourselves as far as we can in terms of we want to challenge our mental math capability a little bit. Okay, and so now I just now cleared up that way. The base for a logarithm doesn't have to be a whole value as long as it's positive and it's other than 1. Okay, so we're good with that base right here. And so now in that case, theoretically speaking or literally speaking, even an ugly number, an ugly value as well, as ugly as pi right here. Okay, as long as the number is positive and other than 1. Pi is positive because pi is approximately, we learned this since 3rd grade or maybe 4th grade, okay? 3.14 and a lot longer. So surely it's above 0 and it's other than 1. So as long as we run into a number, as long as we have a number that meets the 2 requirements here, positive and other than 1, that can be the base of a logarithm problem, of a logarithm operation. So in other words, so now after I pointed that out, then just for your awareness, okay, I raised this up just for your awareness. So we can also have, depending on the needs out there, depending on the applications out there, it is entirely possible to work with a log base pi of a value, say 5 here. Okay, that means we just need to find out, hey, what power of base pi equals 5? What power of base 3.14 to equal 5? But of course, now I'm not saying that we can get the answer here with without a calculator, with the mental math capability that we have right there. I'm not saying so. So don't get me wrong on that. With something like this, we need a calculator. Okay. So there are problems that we operate with log and we need a calculator. There are some other problems that we can challenge our mental math capability a little bit. All right, and so that's the idea right here. And so for your own curiosity, again, I still have not at this point taught any work with how we can use the calculator yet. I would like to save that as one formal section of the lecture here that I can talk about that. Okay, because I want my students to have more experience with log before we use the calculator. Okay, so now in my own experience, allow me to just simply share the answer, and I will, again, one more thing I owe you. Okay, you will get to that point of how I got this number. Right now it's just something I tell you. Okay. All right, so I just quickly stepped out to my computer, to my calculator at the computer station, and I graph an answer, and that answer here, and again, we will get to that point where you will know how I did the calculator, how I work with the calculator to get this answer. Right now it's just to inform you that the answer for this, in decimal, of course, okay, 1.406, that's after I rounded to 3 decimals. Okay, but later on when you learn about your calculator work and how to get these answers, and a lot of times they go nasty decimals, watch for your own rounding, and when you get into doing an actual assignment, doesn't matter whoever you are with as your instructor. Okay, so that's the answer for this. All right, so my point now again is that as long as you have a number being positive and being other than 1, we can legally have that number as the base of a logarithm operation. All right, and so now I brought you to this base pi right here for a reason. Okay, so now there's a reason why I asked you, I asked at the beginning of this lesson that this video must be learned after you have already learned about what an exponential function is, because when we work with exponential function, I also introduced the kind of base where it's base e. Okay, I mean just e itself. Now if you link back, if we recall from that lecture right there, and then here I can briefly mention again, e is just another, for now at our beginning level right here. Okay, in a formal college algebra course or pre-calculus course. We don't need to know how the value here is derived, okay? It's calculated, but E is another known constant to the human math history right here, 2.718, and a lot longer. But that's about all we know. Similar to the pi. So pi was introduced to any one of us. Since I was introduced to pi since I was, third grade or fourth grade, and I believe it's the same with any one of you viewing this lesson. Pi is 3.14 because we learn about circles as early as third grade or fourth grade, calculating area or circumference of a circle. Okay, but E E comes to us much later. Okay, because when our applications applies more and more into the world, into other kinds of problems other than circles, right? Then we need that constant E right there. Okay, but now in the end, at this point right here, simply we only need to keep that E is a value, is a known constant, okay, in the modern math right there. And with the value approximated here, surely E is positive. Okay, and surely E is other than 1. All right. And so now just like exactly alongside with what I said earlier, as long as we looked at a number, as long as we're working with a number positive and other than 1, that number will well qualify to become the base of a logarithm. All right, so in that way, ladies and gentlemen, yes, there is now legally a log base E, okay, of a value, like say log base E of 5 right there. Okay, I'm not saying that we can use our mental math skill to calculate the answer of this. It just means E, what power of E to equal 5. Okay, as far as understanding our goal to find the answer is. The answer for that means, okay, what power of base E to equal 5. And we need a calculator. Yes, we need a calculator. All right, we need a calculator. And so here, so now for this one right here, I only need to state that we need a calculator, but I'm not going to head over to my computer station to grab that answer in numerical value right there, because there's no need for that yet at this point. But my intention for bringing this up is that base E is another special base. It's another special base where we have another worldwide convention for this. So log base E, yes, that's how we understand. That's how we understand that. Okay, but now this is another convention. Okay, and now this convention has become a worldwide standard. That's another convention. So earlier I introduced that log base 10, we write log and we skip the base. Okay, so now log base E. Okay, so I brought that up just for you to understand that, hey, there is a log base E existing out there. There are log base E problems existing out there. I brought that up. And in order to do the calculation, we need a calculator. Because the base itself is already quite a scary value in decimal. Okay, but now I'm showing a convention regarding the symbol, the notation. Okay, so log base E is anytime we come to log base E, we don't write log base E, but we write, and so I'm saying it's written as, okay, log base E is written as another convention to write symbol for another base of a log right here. We write that as an ln, okay, ln, and then whatever number that is, that's there, okay. And so now that means right in this. So just like how I was saying earlier about the log base 10, yes, when we're reading it out loud, we still read log base 10. Okay, when we're trying to find the answer, we still think of that as that question: what power of base 10 equals a number? What power of base 10 equals that number? So the same here. When you say it out loud, you say log base E of 5, meaning what power of base E equals 5. Okay, but then no one in the world in these days writing log with the subscript E right there. Okay, so to communicate with the worldwide mathematicians out there, we write ln. So that means as an impact, this one right here, log base e of 5, okay, is the same. Is the same as, and really we write that as ln of 5. We put 5 in parentheses. Or you can also alternatively skip the parentheses, ln 5 like that. All right, so that's what it means right there. So this is just a symbol. Log with the subscript e right here is written as ln. It's written as ln. It's a worldwide convention now for writing logarithm of base e. Okay, so just like how I was saying with log base 10, nobody in the world in these days writing log subscript 10. They write log, just log, skipping the base 10, because that's the convention. So now here's another convention. Log base e is written as ln. So log base e of 5, we write ln of 5. This is the worldwide accepted the standard right there, convention right there. All right, and so now back to the question. So now you understand, we understand clearly log base e is written as ln, or anytime you see ln, it means a log base e. All right, so now let me start showing you a couple things that I've been hiding as secrets, but then I didn't mention all the way to the end yet. Okay, so back to that question I was bringing up. I couldn't show I didn't even bother showing the numerical answer earlier. So now this is log base e. This is the way we read log base e, okay, of 5. And of course the answer, don't expect the answer to be a nice whole value or nice looking number. Okay, so now this is what we can do with the calculator right here. For when it comes to log base e, we have a little bit more flexibility. Okay. All right, so now with my calculator program right here, anyone with a standard TI 83 or 84 will work exactly the same way with whatever my machine is doing here on the computer screen. So to calculate log base e of 5, right on your TI 83 or 84 calculator, there's a key right here that says ln. This is the key designated for log base e right here. See, just as I said earlier, this is a worldwide convention. Okay, so ln and 5. Now we get the actual numerical answer. So as I said, we won't be able to find the answer here with our mental math skills, so we need a calculator. So now the answer there in 3 decimals, that's what I usually go with when I lecture. Then it's 1.609, but really it's a lot longer than that, and it's still even longer than this. Okay, it's just our calculator is not able to show any value longer than that. All right, so that means our answer here, as we saw on the screen, and just now you've learned how to operate with your calculator. So 1.609. Okay, so that's the answer right there, but it's still a lot longer. So I shouldn't say equal. I should have said approximately equal. Okay, and so now on the screen structure that I just showed earlier, then you can see that aside from ln, okay, aside from ln, we have another key that's labeled log. Okay, log, and this is that symbol designated for. This is the symbol that's designated for log base 10 right here. So this is log base e and this is log base 10. Okay. So for example, when we need to, if we run into a problem like say log of 200. Okay, this is not a number where we can do the math mentally right here. This is not a value that we can do the math mentally. Yes, we understand that this is base 10, so what power of base 10 that equals 200? Yes, we understand the operation here in terms of that question. But in the end, what is the answer? We need a calculator. Okay, and now with this log base 10 operation, we do have a button, we do have a key on our calculator, on our standard calculator for that. All right, so on our calculator here, it's log, and just type in 200 as usual. Okay, close up parentheses. And this is the reason why I highly recommend my students, anyone learning with me, to use parentheses as a habit, because most of the technologies that we're using in these days that rely on parentheses. All right, so now log base 10 of 200. Okay, log base 10 of 200. The answer for that is approximately 2.301. Okay, 2.301. All right. Approximately 2.301, and a lot longer. All right.